Let's talk about the third angle's theorem, because that can be quite useful. If I have two triangles, and in each of the triangles, I tell you that this angle is congruent to this angle, and this angle is congruent to this angle, what else should we be able to conclude? Well, let's imagine we actually have angle measures, such as I know this is 60 degrees and I know this is 70 degrees. Well, because of the triangle sum theorem, we know how to figure out this third angle. All of the angles have to add up to how much? That's right, 180. So if this is 60 and this is 70, well, 180 minus, well, what's 60 plus 70 put together? 130. So minus 130 gives me 50. This third angle has to be 50. So if these two angles are congruent to these two angles, and I know these measures are 60 and 70, then I know this one has to calculate to be the same thing because it's a triangle, and any triangle, the angles add up to 180. So without having to do calculations, I know automatically that these angles, the third angles, are congruent to each other. So the third angle's theorem just tells us we don't have to do that much work. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent to each other. Let's see how that can be useful to us. In this picture, I need to use the third angles theorem to solve for the variables. Well, I see that these two angles are congruent to these two angles. That means the third angles must be congruent to each other. So once I calculate this angle measure, I automatically know this angle measure. So 110 plus 30 makes 140. And if I subtract from 180, I get 40. So this angle's 40, therefore this angle's 40. And now I know x is 40. The third angle's theorem allows us to not have to do as much work in this problem. Remember, vertical angles are always congruent to each other, so I'm going to mark these vertical angles congruent. Once I know the vertical angles are congruent, well, I only have one other angle left in the triangle. This angle is the third angle from this one. This angle is the third angle from this one. Therefore, without having to do any calculations, I know that x has to equal 65. Pretty cool, right? Let's look at some properties of congruence that also can be useful in proving things. The reflexive property is a really useful one. Think about a reflection. When you look in the mirror, you see yourself. Well, when I make a statement where I see the same exact thing on both sides, that's called the reflexive property. Why would I make that statement? Well, in this picture, see how I have triangle ABD and triangle ABC? Because they're both using side AB, I can automatically say that AB is congruent to itself. Now, if I had these two triangles separate from each other, like this would be side AB and this would still be side AB, and I would mark them congruent because they are the same side. I'm going to label these other points too, just because. But in the picture, I just put one congruent slash, and I can write the corresponding parts. AB is congruent to itself. Another property that you'll see from time to time is the symmetric property. Think of symmetry. Symmetry shows us that if it looks one way in one direction, we can flip it around and it looks the same in the other direction. Another very useful property is the transitive property for congruence. This property, and you've heard transitive property before, transitive property is like transfer. I'm transferring from two congruent statements to a third. It's kind of like the law of syllogism. Let's see how that works. If AB is congruent to CD and CD is congruent to FC, then AB is congruent to FC. Notice what we did. Both of these are congruent to the same segment. CD is like the link in the chain. So now I can connect from one of them to the other one. Similar to the law of syllogism, going from the beginning of the story to the end of the story, or this one transfers to this one. So connecting those two gives me that conclusion. Let's look and see how in the picture that could be helpful. AB is congruent to CD. So I have a congruent slash here and a congruent slash here. CD is congruent to FC. CD has 5 millimeters and FC has 5 millimeters. Therefore, AB and FC are congruent. Segment AB and segment FC both must be therefore 5 millimeters and congruent to each other. Let's see how we can use some of these properties and theorems that we've learned so far. Use properties or theorems to mark the pictures with any extra information about what might be congruent. Then write a congruent statement if possible. So in this picture, I see two triangles are attached. So I'm going to put a congruent slash here. Now see, I've marked a 1 and a 2, so now it's time for the third slash. Because this segment is the same as itself, I'm going to say ZM, segment ZM is congruent to itself, segment ZM, and it's by the reflexive property. So I'm going to make sure that I write down that it's the reflexive property allowing me to mark that it's congruent. Now I see that everything has markings, congruent angles, and congruent sides in the two triangles. So now I can write a congruent statement. Triangle AMZ is congruent to triangle BMZ. I'm matching up the corresponding parts. What can we say in this picture? Well, I have parallel lines. Parallel lines allow me to mark special angle pairs, like here's my zigzag to give me these alternate interior angles. Well, I could do the zigzag the other way. And now I have these alternate interior angles. So I'm going to say that angle H is congruent to angle B. I marked those. And I'm going to say that angle J is congruent to angle N. And the reason for those is because these are alternate interior angles. This is the alternate interior angles theorem. But alternate interior angles is the main part that we want. Then I've got vertical angles. So I'm going to say that angle, now I can't just say Y because that's too vague. I have to use the three-letter name like HYJ. Angle HYJ is congruent to angle BYN. Make sure I'm matching up corresponding parts, and it's because these are vertical angles, or because I'm using the vertical angles theorem. Now I have everything marked that I need in the picture. So now I can say that this triangle is congruent to this triangle. Triangle HYJ is congruent to triangle BYN. Let's look at one more. It looks like everything is marked to everything in this picture except for this last angle. Well, remember the third angles theorem tells us that we can mark these third angles congruent. So I'm going to say angle KSL. I have to use the three-letter angle name because S is a point that could go for a lot of different angles in this picture. KSL, and so I went 2 slash to 1 slash to 3 slash, so I have to do that again, AQP. And it's because we used the third angles theorem. Now I have everything marked to everything in this picture, so now I'm going to make the congruent statement with triangle KSL being congruent to triangle AQP. And there you have it. Finally, let's do a little summary. Use your own words to describe what it means for figures to be congruent. Where outside of the classroom do we see congruent figures? See you in class.